So welcome to Basecamp Cohort 4. This is session 1 of 7. Okay, my name is David Barreto. I'm one of the developers advocates from Starkware, focused on StarkNet, of course. You can see here my socials, my Twitter, my blog as well. And I'm here with also Manmeet and Omar, who are also developer advocates from Starkware. So in this cohort of Basecamp, cohort 4, we're going to have 7 sessions in 7 weeks. Each session lasts for 2 hours. What we expect roughly is that out of those 2 hours, 90 minutes is going to be the presentation or some live coding. We have 20 minutes for questions, which you don't have to wait for the end, or just whatever question you have, use the Q&A, and Manmeet and Omar will do their best to try to answer them. If any of you don't know the answer, you want to discuss it, please, Omar and Manmeet, interrupt me. We have a discussion live as well. We will share in the Q&A for you guys after the session in an email, so you have that as a reference. We will have 10 minutes break as well. And just so you know, the last session of Basecamp Cohort 4 is going to happen May 24th. So it's going to be kind of like 2 months in the future. We have some homework, but it's optional if you want to do it or not. Just take Basecamp as a way to learn everything about StarkNet and Cairo. It's up to you how much you want to get out of that. So we don't have any formal graduation. We're going to be reviewing the code. We're just here to support you. That's why the Discord is important. If you get stuck with homework, go to Discord, try to get support from your peers. We will also get to hang out there to help you guys as well.
David, there's a question regarding the slides. Can we share the link?
Oh, yeah, yeah. That's a good point. Yeah, okay, let me file, share, publish. Is there a Q&A? Yeah, can we have the slide? Yeah, type an answer. Here's the link.
The chat, that will, so it stays there?
In the chat as well? Okay.
Yes, please.
Right, that should be working. Is it working for you, Omar? Manmeet, can you open it? Or anyone in the chat can let me know if you can open the slides. Okay, cool. People are able to look at the slides. So as I mentioned, we're gonna have 7 sessions for Basecamp. So today is about fundamentals, just the getting started about everything about StarkNet, Cairo. Hopefully to have a basic dev environment set up in our machines and to deploy an example of smart contract to StarkNet, so you get to interact with the network as well. Session 2 next week is going to be a deep dive. So basically, it's like a part 2 of this same talk today. Session 3 is actually about Cairo 1, going through the syntax. If any of you have been at StarkNet for a while, you will know that Cairo 0 is a very different language from Cairo 1. So we want to take some time to go through all the details about the syntax. Session 4 is about testing and how to test Cairo 1 smart contract. Then session 5 is about the StarkNet's architecture. We will see some architecture today at a foundational level, but then in session 5, we're going to go deeper into it. Session 6, we're going to look at Cairo's architecture, because Cairo has a very specific CPU architecture that we're going to discuss there. And the final session is going to be about Starks, the ZK proofs that underpins StarkNet. Okay, so some things that you should know is that after each session, you will receive an email that's going to have a link to the recording. It's going to be a link to a YouTube video, a video that's going to be unlisted, so you will need the link to see it. We're going to also share the Q&A from the session. That's why we're trying to push people to have any question, use the Q&A, because that way we can share with you after, so you have it as a reference. We're also going to send a feedback form, because we want to hear from you guys. How do we improve Basecamp sessions, not only Basecamp in general? How do we improve for next session for next week? So please give us your feedback. We're going to tell you what's going to be the homework in the email, and also a form so you can submit your homework, in this case, any GitHub repo or your StarkNet address where you actually deploy it. Use the Q&A system to ask questions instead of the chat, and use Discord to get help from peers. So if you provide your Discord username when you register to Basecamp, you should already been added to a private channel on Discord in the StarkNet the StarkNet channel, the StarkNet City Discord server. If you didn't, it's because there are some issues. Either you were not part of the Discord server, so try to first of all get into the Discord for Starkware, and then we will add you. Some people we were unable to actually add you because there's some rules about security about the bots that we cannot bypass. So I'm sorry if that's one of you. If that's your case, please use this session to ask all the questions that you have. So for today's agenda, we are going to cover why Cairo, why StarkNet. So Cairo, the programming language, StarkNet, the layer 2 with Cairo is used. We're going to also see a basic view of the StarkNet architecture. We're going to do some also basic view of Cairo 1. We're going to discuss some of the tooling that you have available as a developer. We're going to have a little break. And then we're going to do some live session setting up a basic dev environment from scratch. So I'll be using, in this case, a VM with Ubuntu, so you can see the whole process from start to finish. And we also have that documented. I'll share the links to where that is being documented. Any interesting questions, Omar, and me to discuss now live? You can vote on your favorite question in the Q&A as well, so that gives more visibility. All right, we lost some Manmeet. So this is some question here. Which Discord server channels is dedicated to the Bootstrap, the Bootcamp? Thank you. It's called Bootcamp, Basecamp Cohort 4. Yeah, that's inside of the StarkNet Discord server. All right. Let's get started. So why Cairo? So I like to start this with actually a story. So imagine you are the head of a space exploration agency in a small country, and your task is to send a spacecraft, a small one, like a robot, to a planet, let's say Mars. So of course, you have to do a bunch of calculations. Maybe the most important one is when is the right launch window and the best trajectory. So you use the least amount of fuel. So, you know, the rocket is the smallest as possible, and it takes the least amount of time. So those computations are very complex to perform, requires a lot of computing power. So probably you will go to your engineer and say, hey, could you write in the algorithm and some very high performance language like Rust, for example, so we can get those results. We can just know those two variables, the best launch window and the best trajectory. So sure enough, they create the algorithm, but it's very complex, and because it's so complex, it actually requires a supercomputer to be executed in any reasonable amount of time. But you have the issue that you don't have a supercomputer because, you know, you're in a small country, you don't have access to a lot of resources. But there is a rival country that is being willing to help you out. They actually have one, and they have offered to execute your code and give you the answer. But then you have the issue that, sure, you can provide the code to them, to the rival country. They execute it in their supercomputer, and they will give you back the answer, right? So they give you those two variables, the launch window and the trajectory. But then you have a problem. Like, how do you know that that is the right answer? That is actually the result of executing your program exactly the way you write it. How do you know that the supercomputer didn't malfunction, like one bit flop during the calculation? Or maybe there was some kind of sabotage. Maybe it's even a small change in how the computation is performed could be a disaster for your space exploration. So you don't have a way to meaningfully, to be convinced that that result is actually what the algorithm that you wrote or your team wrote actually was supposed to find. So not even with any traditional language, you cannot have that certainty. Not even Rust, not C, not any language. But with Cairo, you actually can, because Cairo is a provable language that when you execute it, let's repeat the scenario. This time you write the algorithm in Cairo instead of Rust. You provide that code to the supercomputer of the rival country. But now then, because it's being used with Cairo, not only they will give you the result back, they also will give you a cryptographic proof that verifies or will let you verify the validity of the computation or the integrity of the computation. So now you can take that proof and you can use any regular computer and just verify the proof. And that verification will let you know in non-certain terms or in a mathematical certainty way that the result that you're getting is actually what was supposed to come out of the execution of your program. This is called computational integrity. So now, if the execution is intentionally or unintentionally modified, the proof will be invalid and you will know it right away, right? So there's no chance someone's going to sabotage your program or that there was some malfunction and you didn't know. You will know right away. So with Cairo and the fact that you get cryptographic proofs out of execution, a regular computer, in this case a laptop, is able to keep a supercomputer honest. And that is a superpower that only languages specialized like Cairo, specialized for validity proofs, can provide. Okay. Just a sec. Trying to make the Q&A visible for me as well.
David, just one question here.
Yeah.
Do we have a channel in Discord for these cohorts?
We do. Someone actually provided Basecamp Cohort 4. That's the name.
Excellent. Thank you very much, Shipping. I saw that you. Okay. Perfect.
Yeah. If you provided your Discord username when you registered, you should be in the channel already, unless you were not part of the Discord server. So if you were not, try to join the Discord server for StarkNet, and then we will review the list again and add the new people that enter the server later.
David, if it takes just a second, could you please add me so I can also take a look at the questions and be able to answer them on Zoom?
To add you to Discord?
Just a Q&A. I have the Discord.
I don't know.
Oh,
I don't know. Why you
to add you can just open the window.
Yeah, but it's not opening.
Yeah. We can figure this out.
No. Yeah, no problem. Go ahead, David. And
Yeah.
Perfect. Okay, so we have a lot of questions here, but we're going to answer them and let you know what can we answer live.
Let me just try to answer a couple of them. Maybe you can type the answer as well, so they have it as a reference. But let me just interact with the audience. Let me see some of the questions. At least the one have been voted that have not been answered already. Sir, I skipped the intro. So what do I have to do to graduate? Can I attend all the sessions 100%? Do the work. We don't have a formal graduation this time. We're going to give you homework. It's up to you if you want to do it or not. Just take Basecamp as a way to learn as much as you want from Cairo and StarkNet. This is because we don't have capacity to assess hundreds of people submitting homeworks every week in a reliable way. And we realize that the goal here is just for you guys to learn more on anything.
Yeah, we can do cool stuff and I don't know. You will see that it goes to something. It will be worth it.
Fox says we really have to focus on Cairo 1. No reason to do Cairo 0 anymore. Yes, in this Basecamp we're not gonna do any Cairo 0. It's just all about Cairo 1 this time. Just be mindful. Cairo 1 is super new. Was just released to mainnet very recently, so it's gonna be a little bit rough around the edges, but it will improve over time. How can we ensure that the proof is not tampered? So the probability of you being able to create a cryptographic proof that's going to fool the verifier is 1 over 1 billion times 1 billion times 1 billion times 1 million. So it's very, very, very small that you can actually do that. To understand exactly the reason why, you have to wait until session 7 when we discuss actually Stark, the math behind these validity proofs. Please turn on caption. It will be super helpful. You know what? I tried last time. I don't know where it is. Can you, Omar, you're the host, can you take a look to see if there's a way to enable captions? I know the last time or some previous time we were able to. I just don't remember where.
Sure, I'm looking for this. I don't promise anything. What are you like?
All right, let me continue. Omar, if you see any interesting question, please interrupt me and we can have a discussion.
Sure.
Okay.
Are we gonna? I don't know. Go ahead.
Okay. So to summarize, why Cairo? So first of all, it allows you to create what's called a provable program. You can create a cryptographic proof that attests to the integrity of the computation. So as I mentioned, the cryptographic proof is generated alongside the result. Proof verification can detect cheating or malfunctioning without re-execution. And that last word is the key to why we use validity proof for scaling Ethereum. We're gonna look more into that in the next section. So you can summarize this by saying that a regular computer is able to keep a supercomputer honest when you use a language like Cairo. Okay, so we talked about Cairo. So why do we need StarkNet? So let's think about the issue of scaling on layer 1. So just a second, I disable Discord because I hear so many notifications that it distracted me. Okay. So in layer 1, in case of Ethereum, we have what's called a block producer, which is going to give you, it's going to tell the network, hey, here's the new state of the network. Let's say the state is 42. But of course, all the other validators in the network, they just don't going to take the word for it and say, oh yeah, sure, it's 42. They will actually execute independently the same block and verify that they all get to the same result independently. So that's part of the consensus, that the actual result, they all get to a consensus is actually 42. So as you can see, even a small or a simple computation takes tens of thousands of computers to actually execute, right? Because they all need to execute that independently and get to a consensus. So you can see that is fairly inefficient in that regard. So this is how Ethereum achieves computational integrity, but by re-executing the same transaction over and over. In the case of StarkNet, we execute only once, but then we verify everywhere. So when you, on a StarkNet, you will do something similar. You process transactions, and then you propose a new state. Let's say the new state is 42. But not only you provide the new state, you also provide the cryptographic proof. And now the validators were just Ethereum nodes, Ethereum validators. They don't have to re-execute the same block to see if it's 42. They only have to verify the cryptographic proof that was provided. And that will give them mathematical certainty that the actual answer of the new state is 42 without having to re-execute all the transactions in the block. And as you can see, the verification takes only a fraction of the actual underlying computation. So you can see visually here why a layer 2 like StarkNet is so much more performant, because now you don't require every single node of the network on layer 1 to re-execute all the transactions. They only need to verify the cryptographic proof, and that takes much less effort. What's the connection? How less of an effort? Well, if the execution takes n steps, right, the execution done by the sequencer on StarkNet, then the validation of the cryptographic proof associated with it actually takes log square of n. So this polylogarithmic relationship, and it's easier to see in this graph. So this blue line going vertical, going in the diagonal is actually the amount of steps of certain computation. And you can see the red line is the amount of steps of the verification of the associated cryptographic proof. So the bigger the gap between these two curves, the more you achieve in saving computing power from the whole network to achieve the same result of creating new states. So you can think of validity proofs this analogy. Validity proof is to computation what zip is to a file size. It's all about compression. Just in the case of validity proof, it's a compression of computation, while zip is a compression of file size. Let's see any interesting questions. Any question here, Omar and Meet?
Yes. Efrain Cuello is asking, what is a honest supercomputer? Honest supercomputer.
You don't need the supercomputer to be honest, as long as they use the Cairo VM, and you have access. We're gonna have to see. You'll need to have access to the underlying Cairo program So we all have an agreement which program is being executed. But as long as the supercomputer uses Cairo VM, it will able to generate this cryptographic proof that the computer will not be able to tamper. Or if they do, you with a verifier independently, you will be able to spot when they're trying to cheat.
What do you mean when you say? Oh, sorry. When you say cheating and being honest, what do you mean? Like, what is cheating in this context?
Cheating will be trying to create a validity proof that try to attest to a computation that didn't happen, or to attest that some computation that apparently happened provide a completely different result that it should have done.
Okay.
And you've been trying to fool the verifier that you have on your side. So it's the combination of both that give the security of a system.
Okay, thank you. Secure workstation.
Please, people in the chat, please use the Q&A. Don't use the chat for questions so we can keep track.
Right. Yes, we're focusing on the Q&A. And also, David, here's a question on how can Aslil join the Discord? I guess they're simply going to the Discord of StarkNet, join, and whatever.
Yeah, if you can share the invite link to the Discord server, put it there in the Q&A, would be helpful.
Oh, also let me invite you to the Telegram. I will send you a link in the chat so you can join the Telegram here of English speakers. It's only for builders, so if you want to go there and we can talk a little bit more and contribute, you can ask questions and so on. So I will send you the link also for the Discord.
Cool, thank you, Omar. All right, let's talk a little bit more about validity proofs. So validity proofs are an implementation of what's called the zero knowledge proofs, or ZK proofs. And it uses ZK proof to guarantee computational integrity. That's basically to guarantee that certain output is a result of a computation with an input. So you can think about that is like doing the right thing even when no one is looking. That's one way to think about computational integrity. So we use validity proofs and ZK proofs not for privacy, which is a common misconception about StarkNet. We use it for scaling in Ethereum. As I showed you before, the comparison of the layer 1 and the layer 2 validators. So StarkNet right now is not about privacy. It might be in the future, but right now it's not. That's why we think that ZK rollup is a misnomer, because it can imply some privacy. We prefer the term validity rollup for StarkNet. And to be fair, pretty much any other ZK rollup out there uses validity rollups. None of them, to my knowledge, actually are focused on privacy after, I think, Aztec shut down their own layer 2. And very importantly, the type of ZK proof that StarkNet uses is Starks. We don't use Snarks. Probably you have heard both being ZK proofs, but we use Starks. And there's an important reason why we chose to go with Starks and Snarks that I want to review here. So if you compare these two types of ZK proofs, the verification time for a Stark proof is polylogarithmic, right? If you recall the chart that I showed you. In the case of a Snark, it's actually constant. So it doesn't matter how complex the underlying computation is, the amount of work to verify the computation is always the same. Now, the proof size that we send to layer 1 for verification in the case of Stark is pretty big. It's about 400 kilobytes. In the case of the Snark, it's pretty small. It's only close to 300 bytes. So it begs the question, if the Snarks are so much better than the Stark, why did we actually choose a Stark and not Snark or StarkNet? There are two important reasons for that. First of all, when you use Snarks, you have to go through the trusted setup, the trusted ceremony, where you have to feed the system with a secret, and you have to make sure that the secret is properly disposed, because if that secret is being leaked, the whole system is compromised. In the case of Stark, we don't need a trusted setup. It works even without that. So it's one less trust assumption for the security of the system. But also very important, the Starks are quantum secure, which the Snarks are not. So whenever quantum computers come online with sufficient power, they will actually break a Snark, but they will not break a Stark. So we are making a bet on the future to, the maximum level of security that we can think of. Of course, that has a price in the proof size, but it's better to be safe than sorry in the future. That's how at least we'll be thinking.
David, good question here. So there are some people that join the Discord of StarkNet, but they have not been added yet to the channel. So what will we, how can we proceed in that case?
If you joined just recently, allow me some time to get in touch with the Discord mod who is in charge of the channel so they can add you. Just make sure that you actually provided your Discord username when you register, and we will try again to add you to the server. Some people might try to join the Starkware server and might not be able to, and that's because some security bots. That's something that we cannot do anything about that. But if you actually were able to join, we will add you to the Discord server just maybe tomorrow morning.
Maybe they can send their Discord name in the chat, right? And we can add them.
Omar, if you can take the note of that will be super helpful.
Perfect. Okay. So if you
maybe start Q&A and people add their Discord username, so we have one place to track all the people who were not added to the channel.
Oh, no, I think it's okay in the chat. We can download it and then okay. Yeah. So please add to the chat your Telegram, your Discord name in case you haven't been added to the Discord channel, and we will add you. Thank you.
Okay, let me see more questions. I wonder if there's a way to hide the one that's been answered. Okay. Bartos answered, is there a possibility to keep the algorithm private so the supercomputer cannot steal algorithm and they use it later? And not now, no, because as I mentioned, the StarkNet is not about privacy, it's about scaling. And so you have to share the algorithm. So basically when you use a StarkNet, you have to publish your smart contract so it becomes visible to anyone to use it.
If you answer it, David, please click on answer live so we know you already answered.
Okay.
There's two questions from Fox from XLP. So, man, you know that there are. Okay. What do you think about the snarks using without trusted setup? They are using some kind of BRFs. What do you think about them?
That I'm not sure. I haven't digged so deeper into the tech stack to know what's the implication. But I know that for Ethereum, there's a push right now for KCG commitments, I think. That's part of the secret, right? We're all collectively creating a secret to feed into the system to provide security to the stacks. So that's why it can be done, but then you have to make sure that you do the KCG commitment ceremony correctly.
Can I pause for a second? So real quick. So when you have a circuit and the verifier has to read it, so basically you have two parties, prover and verifier. All of this trusted setup, yada, 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 is basically done. So the verifier can read something shorter than the actual circuit and verify that the circuit is correct. So we have to, as David has been saying, go through some sort of a compression process from circuit to compressed information. And then that compressed information is what the verifier reads. This compression requires, in the case of snarks, which is the first protocol to have been introduced in this space, it requires some randomness. Now, whether you use verifiable randomness or, I guess, unverifiable randomness, that doesn't change. The security vulnerability that we are talking about is that even if you do have verifiable randomness and someone is able to get access to that or leak that information after the trusted setup, then the prover can basically cheat and create false proofs, and the verifier will not be able to figure out what's going on. So that's kind of like what we're doing here. Starks require no randomness to generate. They only use a collision-resistant hash function, which is also why they're quantum secure. So that's kind of like just a fundamentally superior tech stack, I guess.
There's a very interesting question from Zeberin Islary that says, aside from blockchain, where can Cairo be used? Let me I see some very good answers already from your peers. So let me just provide my own answer as well. One example that I like to think about is in the future, you should be able to generate proofs directly on your computer, right? and then submit the proofs to some server, and the server is the one who runs the verifier. And I like to think gaming is a good example of this. When it's a common issue in gaming that people actually modify their client to cheat, right? And that's an issue when you have a multiplayer game. With a language like Cairo, you can technically request your client to every so often create a validity proof out of the execution of your client and send that validity proof to a server, which runs the verifier just to check that you are not cheating, that you are actually executing the client the way that it was supposed to be, right? So if you try to cheat, if you try to modify your client, the server will know because the validity proof that you send regularly will fail. So that's one use case. And there are people actually doing research in the topic to actually run even on a smartphone. The main issue right now is that creating proof is a very resource-intensive process. So there's a lot of research that needs to be done to get to that point. But it's an interesting thought as well, how to use Cairo in a different setting that is not StarkNet.
We're also doing something with Bitcoin, right?
Oh, that's great. Yeah. Can you explain? Can you elaborate? Any of you?
To be honest, I cannot elaborate. I have not very aware of what is happening, but I know that there is something being built. I will send you the report to the chats. Something is being built. I don't know exactly what, but it is in order to scale Bitcoin. You should start. Yeah. And it has been very successful within the Bitcoin community. So, that's something we can say about it. And also, David, there's a question about the prover will be open source.
Let me first answer the question about the Bitcoin. Actually, that's something that the Bitcoin community is very well aware of. I think the Ethereum community is not as much, but on the Ethereum community, they're actually using our technology to create a very light Bitcoin client. They basically, I think the basic idea is that a cryptographic proof or validity proof is generated out of a regular Bitcoin client. And then when you want to sync a new Bitcoin client yourself, you don't have to download the whole blockchain to calculate the UTXO yourself. You can just verify the cryptographic proof of all the calculation that other server actually perform for you. And then you can sync to the latest UTXO, just download the database and verify the cryptographic proof associated with the execution to get to the current UTXO. So now you can sync a Bitcoin client in a matter of probably minutes instead of days. I forgot the name of the project. Was it Zero?
Clement here has Zero Sync. Clement Kofet here added the link to the repo in the chat. Thank you very much, Clement. You can go and see it. To be honest, there's a lot of very cool stuff that is being built right now at the edge of the technology. So, and the Stark community is amazing. To be honest, it's amazing. They are building some very cool stuff, and yeah, it's great. David, do you want to do the prover open source question?
The prover open source, yes. So right now it's not open source, but we made a commitment to we will make it open source. We're just trying to tackle other areas of the blockchain first, especially the sequencer is our first target. It's just we're doing a full rewrite in Rust, open source. Want to decentralize also the sequencers before we can tackle the prover. But it is the goal to decentralize the whole stack. It's just not yet. We're not at that level yet. So right now, the sequencer and the prover are actually centralized, which is the same for every other CK rollup right now. That is centralized. Some of them are actually open source. Yeah, go ahead, Omar.
Okay. There's also a question from Paul asking, can you explain why Stark is quantum secure and not Stark? So real quick, the part of the cryptography that is being vulnerable right now to quantum attacks are those using elliptic curve cryptography, such as Starks, as Ethereum and Bitcoin and so on. And the Starks are not relying on this kind of primitives. They are not using elliptic curves. They are using hashing functions as symmetric key encryption. So it is believed that these particular primitives will be quantum resistant. So that's the main reason, the elliptic curve cryptography.
Yeah, at least right now we don't know any algorithm able to break a hash function using quantum computers, but we do know an algorithm to break elliptic curves and other cryptographic primitives using elliptic curves using quantum computers. The algorithm exists. It's just waiting for a quantum computer to be sufficiently powerful to run it.
And the day will come. When we have that. So a lot of development is being done in the quantum computing side. So yes. And one of the goals they have is actually trying to use this algorithm to break the elliptical cryptography. Is actually a metric for how good these computers are. So it will come a day, and when that day comes, the first thing they will do is break this elliptical cryptography.
Yeah. All right. Thank you for the question. Me and Omar, feel free to keep answering them on the Q&A. I'm just going to keep moving forward because of time constraints. All right. So you probably have heard, like in StarkNet, we use the Cairo VM. We don't use the EVM. So why is that? So on one side, you have ZK EVMs, right? Which some famous ones are like the Polygon Hermes, Scroll, ZK Sync. They try to be as compatible as possible to the Ethereum virtual machine, while the StarkNet is actually using its own virtual machine called the Cairo VM. So these two approaches they're trying to optimize for very different things. So ZK EVM is trying to optimize for having max compatibility with current smart contracts deployed on layer 1, but they sacrifice performance because the EVM was created for a particular CPU architecture or a traditional CPU architecture that is not really friendly to ZK circuits. That's why Cairo VM or StarkNet, we decided to create our own virtual machine so we can create or model a computer that is exactly or fine-tuned for validity proofs. So we're thinking about how do we extract the most performance of the network long term. Amit, do you have any more comments? You're more an expert of this area than I am, probably.
Oh, I would leave it at that today, and not deeper, but we can. But yeah, the main difference is, of course, you can compile your code directly into EVM bytecode on ZK EVMs. With us, you have to go through Sierra and but yeah, I'll let you speak more about it.
We have a session 6. It's going to be about the Cairo architecture. So probably a lot of these questions are going to get answered. How the architecture of Cairo actually looks like. Well, how the Cairo VM actually looks like. Just a quick comparison. If you have read Vitalik's article about the ZK EVM classification, he classifies ZK EVM in 4 categories, type 1 to 4. So type 1 is basically no changes to the Ethereum virtual machine, full compatibility, but the performance will be very, very slow to create a cryptographic proof out of those executions. So pretty much no one is attempting this right now. Type 2 is that you use most of the EVM, but you change at least the data structure for storage. You achieve high compatibility. At least you're going to have some smart contracts that you will need to be modified, but the performance is still very slow. Then you have type 3, where you have compatibility, but you have to modify something like storage, hashes, pre-compiled to make it a little more friendly to the new architecture. So you have partial compatibility. It's not like you can deploy every single smart contract as is to a layer 2 with these characteristics. The performance is still going to be slow, at least in theory, technically. And we have projects doing that, like Scroll, Polygon Hermes, ZK Sync, even Kakarot, which is a layer 3 on top of StarkNet, are actually tended to be type 3 ZK EVMs. But then you have the type 4, where they implement a completely different virtual machine. They're not compatible with the smart contracts deployed on Ethereum using Solidity, but the upside is that it's very fast to create the validity proofs. So you have 2 main projects competing in the space. Obviously, StarkNet is one of them, and you can consider it to be a ZK EVM because you can use StarkNet with a compiler called Warp to compile Solidity smart contract into Cairo VM, and the other one is Polygon's mining. So we are really focused on performance and long-term view of scaling Ethereum. Okay, to summarize,
maybe quoting here Eli Sasson, he said, like, we really believe in StarkNet that the future of scalability will be built using Cairo, or Astronaut GVM, because David says the only focus of Cairo, its goal is to scale Ethereum. That is not the goal of the EVM, right? The EVM goal is to maximize decentralization, which is great and it's very relevant. Well, in Cairo, we're already thinking as a given the part of the security and the centralization that Ethereum gives. So now we're focusing only on scaling, and that's why we really believe that Cairo is the way to scale Ethereum. The problem here is, of course, image from David's show. There's already in Ethereum building tooling of Boundary, we have Propel, and so on. And those we don't have in Cairo or StarkNet. We need to build new tooling. However, the tooling is being built by the day. So we have Protostar, which is kind of similar to Foundry. We have actually Truffle, no, sorry, which we have several APIs and SDKs that we can use to interact with the StarkNet and Cairo. So the tooling is getting much better. So we are able to write Cairo and scale both the social parts and the scalability as lower fees and faster transactions.
Cool. Thank you, Omar. All right. To summarize, why StarkNet? First of all, it guarantees computational integrity without re-execution. Proof verification is cheaper than the underlying computation. So remember the polylogarithmic relationship with the underlying computation. We can think about that as computation compression. So we use ZK proof for scaling, not for privacy. That's very important to keep in mind, at least not yet. And we use ZK proofs. We use Stark's ZK proofs and not Snark's, because Stark's are quantum secure. That's really the main reason we're thinking long term. And this is why we have the trade-off. Cool. Let's talk about at a high level the architecture of StarkNet. So in my previous example, the story about the head of the space exploration, the person actually got convinced that the result is 42, whatever that is, right? Because he was able to verify independently the cryptographic proof in his laptop. But then how is other people gonna trust that is actually the result, right? Because so far only this guy was able to verify the validity proof, but not Alice. So that's why for Alice to trust, a couple of things are needed. First, you need to make the Cairo program publicly accessible for anyone. She should be able to independently verify the proof, basically run her own layer 2 node. So she needs a StarkNet. So StarkNet is a layer 2, right? So that's why I present here Ethereum at the bottom as layer 1. So on a StarkNet, when you send a transaction, you send the transaction to what's called the sequencer, right? And the sequencer is like the block producer of StarkNet. And it uses, that's where the Cairo VM lives and also where the StarkNet OS lives. And the sequencer is just going to take all the transactions. It's going to validate them just to make sure that the signature is correct, that the person is able to do these things or being able to use this user account. It's going to bundle them into blocks. And it's going to calculate what's the new state of the network based on the execution of this block, right? Similar to a block producer on layer 1 in this case. The interesting thing here is that out of the execution of all the transactions in a block, the sequencer sends what's called an execution trace to the prover that we call it sharp in the case of a StarkNet. Sharp is because shared prover. It's used by StarkNet, it's used by StarkX as well. So with this execution trace, the prover is able to compute the validity proof to attest to the integrity of the computation done by the sequencer. And this validity proof is eventually sent to layer 1 as cold data to a verifier smart contract that is written in Solidity, right? It's open source, anyone can see it. So the verifier is going to take the validity proof and it's actually going to perform the verification on layer 1. This case is the 10,000s of Ethereum computers are going to perform this computation independently. And if the verification is actually successful, then the sequencer is going to change the state difference, but changing the state before and after the block was executed, again to the layer 1 as cold data, to a different smart contract that we call a StarkNet core. And we use that as our data availability layer, right? We want to publish this data on layer 1. So now we can have full nodes or StarkNet full nodes who gets what is the state of the latest block or the state of the network. It gets that from the sequencer currently, because as of now, these are two centralized entities. But the fact that we send this state diff to layer 1, it means that if for some reason the sequencer or the connection between the full node and sequencer fails, you are able to recreate the layer 2 current state by reading or indexing data from the StarkNet core smart contract. So you can recreate the data from layer 1 independently if you if there is a situation that the signature stop responding to layer 2 full nodes. So at a very high level, this is how StarkNet works. So I went through some of the modules. So as I mentioned, the sequencer validates, executes, and bundles transactions into blocks. The prover creates Stark proofs for a StarkNet and a StarkX. That's what's called Sharp or shared prover. The verifier is a layer 1 smart contract, verifies the Stark proof sent from Sharp. Stark Core is another layer 1 smart contract that just stores. Stores is a big word because actually we only send it as cold data. It's not get stored at the contract level storage for cost reasons. And we use that as the data availability layer. Finally, the full node provides data to layer 2 dApps.
David, can you go a second?
Yeah,
questions?
sure.
Perfect. So regarding the start of your presentation, there was a question from Eliel. Sorry, Eliel, for coming. There are a lot of questions, so we're answering each of them. So Eliel asked, do we send the algorithm or the data to the rival country when you were talking about this part?
We send it. Oh, you mean in the example at the very beginning?
Yes, at the very beginning. So what are we sending, the algorithm or the data?
The algorithm, like the program. You can send, the program. It's just, in reality, you don't send the program as is, you send the bytecode of the program, right? The low-level Cairo assembly program to the supercomputer.
Okay, perfect.
Yeah.
Yes. Okay. Thank you very much, David. A lot of questions from Amit.
Go ahead, Omar.
Oh, no, R is asking, can you use a different data availability layer like Celestia, for example? The answer is yes. We are working on the Validiums, which is going to be a great innovations where we will be able to do the data availability part using different kind of services. For example, Celestia, Filecoin, a USB if you want. So it's going to be very interesting. You will be able to write Cairo codes where you can declare variables that are going to be stored on-chain, and some variables that will be not stored on-chain. It will be stored, off-chain or maybe Celestia or somebody else. So that would be very, very cool with Validium.
Yeah, just a comment. It's called Volition because Validium is what StarkX uses. So we have 3 different data availability modes. Right now, only 2 really. Rollup is the one used by StarkNet, will be published to layer 1. Validium, which is used by StarkX, that we are not covering here, but it's another technology developed by Starkware. And then we have Volition that we want to implement on the StarkNet, I don't know, this year at some point, which is going to allow you to choose where to store your data. So you have different costs for your transaction. You're going to store it on layer 1 or having maximum security, or do you want to store it in some other place that could be Celestia or a consortium of people storing data that's going to be cheaper. So we don't have a lot of details about that, but we know that is a path forward for StarkNet to enable Volition.
David, do you have Curious is asking for the link to the repo of the verifier smart contract layer 1. Do we have those?
Yeah. If you go to Caroline, I think it's here in the Caroline repo. Oh wait. StarkNet docs.
Nice. Also,
It is public. If you go to the Caroline repo, useful info, important addresses, the verifier address. Yeah, that's here. So you can. Is there a question here? I don't know what the question is. I put it on the chat, but Omar, can you please put it on the Q&A? So
yes. The question is, can we get the link to the repo of the verifier smart contract? So I will show it.
All right. So this is the link to the deploy smart contract. To see the actual source code, you have to go to the Caroline on GitHub, and in here, I think it's here. Starkware. Oh man, I know I saw it somewhere here, but I don't remember. Yeah,
no problem. I can search for it. Or yes,
it is. Yeah, it is open source. I've seen it. It's there somewhere. I need to find it. Perfect. Cool. Section 4. So let's talk about Cairo 1. Right? We just recently released this new version of the language, which is very different from Cairo 0, but it's much better than Cairo 0. So Cairo 1 is a high-level language, right? Which makes it easier to learn compared to Cairo 0, which was more of a low-level language. The syntax of Cairo 1 is heavily inspired by Rust, which also makes it like a strongly typed language. So if you know Rust, you will feel comfortable with Cairo 1. When you compile a Cairo smart contract, it doesn't directly compile to the Cairo VM bytecode, which we call it the Cairo assembly. It compiles to an intermediate language called Sierra. Sierra stands for Safe Intermediate Representation, because this is what allows to create validity proofs even when a transaction fails, which was not possible before. And now, because of Sierra, basically, sequencers are always compensated for their work, even if a transaction fails. And in the near future, we allow for transactions to be reverted, much in the way that happens on layer 1. So you can see on the right side, you start with a Cairo 1 smart contract, you compile it to Sierra, and then you send this to the sequencer. The sequencer then compiles to Cairo assembly, that we also call it CASM. And from the Cairo assembly, the execution of this Cairo assembly bytecode by the sequencer, that's where we derive the validity proof on the prover, and we send to layer 1. So take a look. This is how it looks like, an example of smart contract on Cairo 1. You can see at a glimpse, it looks a lot like Rust, where you can do some meta programming with macros. This is how you bring functions into scope. This is how you define storage variables. You have to name a struct storage, has to be the name, and then you define all the properties of all the storage variables. Felt is still the data meta type, but then we have more data types that we can use that before in Cairo 0 was not possible. One very commonly used is U256, which is commonly used in Solidity. This is how you write to storage. This is the syntax. This is how you read from storage. For now, just take a look. Today is not the day to focus on Cairo 1 a lot, just for you to have a taste of how it looks like. And now this is how you define variables with the keyword let, which if you use Cairo 0, you know that before there was like 4 different ways to define a variable. Now we have only one. So it's a much nicer language to play with. So there's a thing called regenesis that is all about closing the gap. So as I mentioned briefly that in Cairo 0, failed transactions cannot be proven. And because they cannot be proven, that opens the door for what's called a denial of service attack on the sequencer, because the sequencer gets to execute a transaction to the point where it failed, and then it cannot add it to the block because a validity proof cannot be created out of a failed transaction in Cairo 0. Cairo 1 actually fixes this problem, but it means that eventually Cairo 0 smart contracts needs to be disabled from the network for security reasons. So we have 2 important events that happen over time. The one that happened recently is the deployment of StarkNet 0.11 to mainnet. Because before 0.11, mainnet only supported Cairo 0.10 smart contract, right? After the deployment of the StarkNet 0.11, now both languages are supported, Cairo 0.10 and Cairo 1. At some point in time, we're going to go through regenesis, maybe 4 or 6 months, where we're actually going to disable all the Cairo 0 smart contract, and only Cairo 1 is going to be supported from that point forward. But in the meantime, we have a migration window where we provide mechanism for you to be able to upgrade your already deployed smart contract from Cairo 0 to Cairo 1 while preserving your same storage layout, the same storage values, the same address. So in a way that is completely transparent to your end users using your smart contracts, but you will have this migration window to go through it, because after regenesis, we got to disable all the Cairo 0 smart contract, and that from that point forward, it's only going to be Cairo 1 from that point on. And this is where we are right now, just at the very beginning of the migration window. So let me go to the summary, and I stop for some questions, because probably there's some. So Cairo 1. Cairo 1 is a high-level language inspired by Rust. Sierra allows for reverted transactions. Before were not possible. We don't have reverted transactions just yet, We need a little bit more work on the StarkNet to allow that, but it's now technically feasible to do it. Smart contracts can be upgraded from Cairo 0 to Cairo 1 while preserving the state and their current address where they're being deployed. Cairo 1, StarkNet already supports Cairo 1 in the testnet and on mainnet as well. And Regenesis will disable Cairo 0 code, and that's going to happen before 6 months in the future. So let me stop here for questions. I bet there's some.
There's a question from an anonymous attendee. Is it possible to build circuits like Circon or Noir with Cairo 1?
I don't think so, because this is a high-level language, but I'm not that much of an expert to get deeper into the reason why. But intuitively, I don't think so.
Yeah, but from what I've seen, you see like a layer 3, we can be able to use Noir, and then that compile it so you can get into Cairo. So it will be interesting. And actually, Francois mentioned something before of you can be able to prove snarks into StarkNet. It's something that's been working in Garaga, I think.
Yeah, you can create your own verifier with Cairo, right? It's a smart contract. It exists. There are the Starks verifier. There are different Stark verifiers as well. So really, you can implement your own layer 3 right now, and not wait for a Starkware or a StarkNet to evolve to the point that we make all these things, like the official verifier available on layer 2.
Perfect. Also, Severin is asking, can we expand more on Sierra? Sierra will be looking at session 6, right? David, more about Sierra?
Probably. We haven't discussed exactly what's going to be covered in that chapter, but probably yes. For now, just keep in mind that it's going to be an intermediate language. So when you compile in your computer before you deploy, you no longer compile directly to Cairo assembly, you compile to Sierra, and that's what you deploy to StarkNet. And then on a StarkNet, the sequencer compiles your Sierra bytecode to Cairo assembly code.
Yeah, this is a great invention. And for those of you who want to, for example, do audits, security audits, learning Sierra will be key for you. It's very important. It's like learning Joule for layer 1.
I see a question. Yeah, more question. Go, Omar. I can see you. Can you order by most of vote, because I see some questions being unanswered with 4 votes, 3 votes.
Yeah, sorry. So we're working on that. We have a lot of questions. So there's a question by Glim. He's asking, Glim, by the way, he's French living in Mexico. Hey, Glim. So in the centralized StarkNet, the sequencer will be a full node, and there will also be a full node that are not a sequencer, right? Which means only sequencers will participate to consensus, and all other full nodes are only relaying data to that or other nodes. Is that correct?
Only sequencer participating consensus. So how decentralized StarkNet is going to look like is a moving target. I don't have a clear answer. Of course, the first sequencer will be the first one to be decentralized, and it means that they need to reach consensus, right? As any decentralized system. Do they need to be full nodes? I mean, sequencer they need to store the current state of the network, right? As well as a full node. But a full node can exist independently from a sequencer, right? They don't have to be the same thing. They can be independently, and I think that's the future. But they will probably share some modules. Like right now, for example, if you use Papyrus as a full node, it uses a module called Blockifier that we are going to introduce also into the new sequencer that is being rewritten in Rust. So they're going to share some of the same primitives for storing the state. But they are 2 different systems in the network.
Also, we have like clients, right? Like Virus being built also by the community.
We also have Virus, which is inspired by, I forgot the name of the other, it's not Horus, it's forgot. There's a light client developed by A16Z for Ethereum that we're using to build Horus on top of that, which I forgot the name.
Yeah, but also worth mentioning that Francois, thank you very much. He has been answering a lot of questions, so thank you very much, Francois. What else can we do? Start recursion to reduce the proof size, like the Mina protocol with snaps.
Is that a okay? Can we do some question? We do that. Yeah, the sharp. Manmeet, go ahead, please. You can answer that.
Oh yeah, so I was just going to say we do not. So initially we generate one proof object per computation, but then basically once we're still in the off-chain environment, we batch those proofs together and keep on generating smaller proofs for a certain period of time. And only at the end of that period of time do we send the one really sort of like root proof down to Ethereum layer 1. So in that way, we're actually getting hundreds of thousands of transactions through one proof object.
Yeah, on session 4, when we go deeper into StarkNet's architecture, we're going to look at how the prover achieves recursion. All right, sorry, let me move on because the time is flying. If we have time at the end, we will go back to see some of these questions. But please try to answer some of them directly on the Q&A. So some of the tools that you should have if you want to get into StarkNet, first of all, is a wallet. And there are two main ones. You have ArgentX and you have Bravos. ArgentX, they have a browser extension. As you can see, for Google Chrome, for Brave, for Firefox. Bravos, the same, also a browser extension, but Bravos also has a mobile wallet, which is very interesting how they implement that and how they use account abstraction. So pick the one that you like the most and make sure that you have it installed in your browser so you can follow along some of the exercises. We have two different block explorers, Welcome Voyager and the other one called StarkScan. Both are great options, so pick the one you like the most. And we have some tools for developers. One of them is Protostar, which right now, I mean, I actually was thinking about removing Protostar for now because it's definitely a full rewrite of how Protostar works with Cairo 1 using a thing called Scarb. So maybe put that on ice in the meantime, but just know that there's a tool similar to Foundry on Ethereum. So you can test your smart contracts using the same language that you use to program the smart contract, in this case, Cairo. And also we have collaboration with Open Zeppelin that they actually develop smart contracts for Cairo, following some of the best practices for, ERC20, ERC20, 721, and so forth. Other tools that we have available, we have a plugin for Hardhat if you want to test using JavaScript. We have a DevNet similar to Ganache as well if you want to run it locally. We have a library for React for your decentralized app. We have different SDKs for different languages, for TypeScript or JavaScript, for Python, for Java, Kotlin, Scala, and for iOS. So whatever you're building, we have an SDK for that. Many of them right now are going through the process of upgrading to support Cairo 1. So just be mindful of that. All right, so let's take a break. 10 minutes. We have 10 minutes. How much do we have? Let's have 5 minutes because we're gonna jump into the live coding session. So just have like a washroom break, get some coffee, and we'll get back in 5 minutes. Sorry, I'm just gonna mute myself and turn on the camera, and I'll be back in a moment. All right, so let's go and set up a dev environment for Cairo 1. So first of all, just a warning, we are gonna be using a lot of tools that are very new. So we're going to be living on the edge, which means that some of these toolings are still rough around the edges. So we have two main repositories that we're going to use. One's called Cairo Lang, which is written in Python, is where we have the StarkNet CLI, and where we have the Cairo 0 to Cairo assembly compiler, right? It's like the old compiler, but it still has the StarkNet CLI. And then we have the Cairo repo without the Lang, that's where we have the Cairo 1 compiler, the compiler to Sierra. And then also we have a compiler from Sierra to Chasm. And I'm going to go into detail why we have two different compilers. I'm going to explain that in section 4, I think. But this one is written in Rust, not in Python. And it also has a VS Code extension that we can use, but we're going to have to build it from source so you can have some, syntax completion and validation as well. So we're going to need 3 main languages for setting up this dev environment. As I mentioned, this is going to simplify as time goes by, but for now we'll go with 3. We're going to need Rust to compile the Caro1 compilers, and I know it's a mouthful, but that's what we need to do, and also to compile the VS Code extension, right? Because right now it's not yet published to a marketplace. We're gonna need Python, particularly 3.9, to create an StarkNet account so we can deploy and declare all these things and invoke. To use the StarkNet CLI, because the Cairo line where the CLI lives is written in Python. And we also need to declare, to deploy, and to invoke transactions on a StarkNet. Finally, we need Node.js for packaging the VS Code extension before we can actually install it on our IDE. So this is the plan for the live coding part. Hopefully you can follow along, but we have the instructions shared for you here at the bottom. So first we're gonna compile Caro1 from source. Then we're gonna test that the compiler is actually working by compiling a simple smart contract, a Caro1 smart contract. Then we're gonna install the VS Code extension for Caro1. Then we're gonna install the StarkNet CLI. We're gonna create a user account locally on your computer. So then you can declare an example smart contract, you can deploy it to StarkNet testnet, and then interact with it using Block Explorer and a regular wallet. So you have two links here at the bottom. I'm using the guide today, but in the StarkNet book, we also have steps for performing this as well. So this ends, okay. So I'm gonna start a virtual machine so we can follow the steps from the beginning, basically. So let me see. Give me a sec to start this. Ubuntu. So this clean install. And start. I'll just know while the VM starts and I log in, share the screen in a moment. Okay, I'm in. And I'm going to follow my guidelines here. So guys, I just tried to set up my computer here with all the things that I need, or I can start doing live coding. Perfect.
Wait, in the meantime.
Okay. Cool.
Okay,
I'm ready. So as I mentioned, I have a clean installation of an Ubuntu machine. The instructions for macOS are very similar. In the guide, I put, whenever there's a small difference, I put there a comment, like an if-else kind of block. So the first step is to install Rust. So to install Rust, you follow the official instructions of how to install it. We want the release version of Rust. So, oops. No, I can't like that. We need to use curl to get it. Let's see how can I increase the font size of this. I'm just gonna proceed with the installation. How is the font size?
Not that good. If you can zoom in.
Okay, yeah. Terminal size, columns, rows, custom fonts here. I already changed it. Custom fonts. Can increase it to 18. Better now?
Yes, looking better. What do you think, guys? They say it's okay. Perfect. Thank you very much.
Make it a little smaller. Yeah. Now, small. Okay. All right, cool. So I have Rust installed. It asks you to activate some things on your shell, so you can just run this source, or you can just close the terminal, which I'm gonna do, and open a new one so the configuration takes place. And just to verify that Rust is installed, at least Rust up, we do this Rust up version, and yes, so we have version 1.25.2. Okay, so Rust is installed, as I mentioned. We need Rust to compile the Cairo-1 compiler from source. So the next step is to actually download or clone the repo where the compiler for Cairo-1 lives. So I have this command here. Copy. All right. So this is the repo where the Cairo-1 compiler lives. And I'm going to clone it to a specific folder on my home directory just called .cairo. I just want to have a particular location that I can always go back to, because we're going to have to do some mapping of the binaries. That's why I put it here. So after clone it, we should have it in the .cairo folder. So if I come here, right? So we are in the repository for Cairo-1. So we need to activate a very particular tag, the latest tag available in the repo, because that's the compiler that was used or supported right now by StarkNet. So we need to make sure that we use the same. So this is why we enable or activate this particular tag, which is the latest tag on this repository, tag version 1.00 alpha 6. Right? So we are in detached mode in this particular commit of the Cairo-1 repo. So now we can actually build all the binaries using cargo and using this command. I'm sorry, I'm going a little too fast just because I'm the guy. Yeah.
Sorry, David. So Rajiv and also Paul Mary are asking if we can share the commands.
Yeah. In the slides which I share with you, at the bottom of the last slide, where I have the live coding plan, you see the reference. Let me just put it here.
And also, if you can share again the link to the slides, that would be great.
Oh, okay. Right, link to the slides. Publish the web. These are the links. Where do I put it in the chat?
Yes, please, in the chat.
Okay, so I put in the chat the link to the slides. And if you go to this last slide before let's start the setup, you see a link to the guide. And I share this link too. This is the steps that I'm following, basically, that you don't see on the screen. I'm just using a secondary screen. But you also have the StarkNet book as a guide. It's just, this is exactly what I'm following in this session. You should turn see it. Cool.
Thank you, Willie.
All right. So going back here. Just a sec. I'm setting up again my environment.
I'm sharing to the chat the link to the StarkNet book,
where you can also see the commands. Please bear in mind that the StarkNet book is very, very new, so we're working on that. But that part is finished.
Could you share that link, Omar?
No, I will share the link right now.
Okay,
link
cool.
to the StarkNet book. Yes.
All right, so the next step is to actually build the binaries, right? Using cargo build, and we use the release version of Rust. We don't want to use the latest or the edge. It's going to take a while, so it's a perfect time to answer some questions.
Perfect.
So let's see. What do we have?
When will the mainnet support Cairo-1? My mic.
It's live. It is supported already. You can deploy.
It's right. There's a problem that he's getting with compiling. Okay, it's a particular problem. I will look at it. Okay, so we already shared the commands. Thank you very much, Crypto Nerd and Rajiv. In terms of energy consumption from Ramsey, from Carnaval, Ramsey, we're looking at that particular question. We don't know, right? But Manmeet already asked internally to see if we can get an answer as soon as possible. Ramsey, thank you very much for that. What are the benefits of the Cairo virtual machine versus zero-knowledge EVMs? They have to be strong for DSL to win with Solidity. And thank you very much, Paul Henry. He answered. that the Ethereum is very specifically used by StarkNet. Yes, exactly. And the benefits is that again that Cairo is focusing only on scalability, and this is something that the Ethereum virtual machine is not focusing on. They focus on other stuff like decentralization, which is very relevant. But the Cairo has the only goal of scaling Ethereum, so that allows to do certain kind of stuffs that make us scale without having to follow all the rules of the EVM, which that are done for different purposes. So the Cairo virtual machine should be able to allow for more scalability. That will be the main benefit. I don't know if you see any other question you want to answer right now, David.
Which one?
Tal is asking, and again, sorry for answering this a little bit late. We have a lot of questions. So Tal is asking, most projects will probably be attracted to zero-knowledge EVM chains because they are already a bunch of Solidity depths. How easy will it be to transpile Solidity to Cairo in the future? Is it better for projects to transpile or to create native on StarkNet? And if you allow me, David, let me quote here again Eliben Sasson, founder of the Starks, inventor of the Starks, founder of Starwa. He said that indeed we will have actually a zero-knowledge EVM. Danilo is leading that development. It is called Kakaot, which Francois already shared. Thank you very much, Francois. But Eli said, our focus here is to scale code using Cairo. So the real scale is going to be coming from Cairo, not from transpilers like the one we have, Warp, will be transpiling Solidity code into Cairo. However, building native Cairo code will be the real power of StarkNet. So indeed, there's a lot of developers already for Solidity, but we think that developers can easily adapt. So most of you, I think, you know at least 2 different languages. I don't know, maybe Python and JavaScript or something like that. And so we would really believe that developers will have no problem learning Cairo also, aside from Solidity.
Also, keep in mind that StarkNet gives you way more resources for executing transactions that's possible on the limitation of a gas fees on layer 1. So that allows you to create more interesting applications. You can actually create things that are not possible at all to create on layer 1. So do you actually want to just transpile your contract as is? You're going to be missing a lot of interesting features. For example, account abstraction. That exists technically on L1 now, but it's a little confusing because there's 3 different ways to have an account on layer 1. On layer 2 on StarkNet, everything is a smart contract. Everything is using account abstraction or smart wallets. So really the idea is that when you have a different environment with different constraints or less constraints, you probably don't want to just rewrite the smart contract exactly the same way as in layer 1.
And it's worth mentioning that any zero-knowledge project following the Ethereum virtual machine, like the CK EVMs, will have the same constraints as the EVM. That being account abstraction, for example. Okay. Do you guys know any open source project that have migrated fully to Cairo so that I can refer to their codes? You can, let me share you the link to the StarkNet Cairo 101, which you can already do. And its code has migrated to Cairo 1, so yes. Also, end-to-end testing. I don't know if we have a project already doing end-to-end testing. So there are a lot of projects migrate to Cairo 1, but they are doing it maybe not open source or experimenting behind the scene. Also, Argent, I think, will have soon their code to Cairo 1, so that will be very good. But in the meantime, I will share to you the Start Cairo 101 tutorials. Those are very, very, very good for you to understand how to structure your code. If you want to learn StarkNet Cairo code, you can learn with it. But it is also very useful to learn the syntax and the way to structure your project. So I will share it to you in the chats.
Compilation is taking a while. It's pretty intensive. And also it's a virtual machine. It's not my host machine. So it has limited resources, but we're getting close.
Perfect. Okay, so DV is asking why not both decentralization and scalability. Start is oriented more to the second one, but I don't see the trade-off to live in the first one. Yes, sure. Well, correct me if I'm wrong here, Manmeet and David, but StarkNet is having both the decentralization from Ethereum and the scalability that is provided. Plus, we will have the centralization in the. There's no layer 2 that is decentralized right now. Actually, we're working on that. We're working on deciding how we will have centralization so we can decentralize the use of sequencers and so on. But I don't know, David, if you want to add something to this part.
No, the goal is to decentralize everything, right? It's a hard problem to solve. It took Ethereum a long time to do it right. It will take us a while also to do it right. So we need to approach it first. Let's see that the technology works, that we can scale, and then we can decentralize. You have to tackle some big challenges once at a time to do it right. But that's the goal, to have it completely decentralized.
With that. Okay, any other questions?
Wow, we have a lot of questions today. That is great. Thank you very much for coming. We're very happy to have you here. I think those are all the questions that we can answer live. We did it. Oh, there's a question from Leo Cesaret. What are the most interesting use cases you are seeing of on-chain apps that will benefit from being able to access more compute? Manmeet is answering right now. Do you want to answer live, Manmeet? Maybe.
Yeah, just like the answer I dropped in the chat, one of the most exciting things that I've been seeing out here in San Francisco is the new push towards ZK AI, because AI and machine learning models are inherently very computationally intensive. So being able to prove inferences so people don't have to run them all over again is actually quite a powerful thing. So yeah, that's one thing off the top of my head, other than the obvious scalability.
Also, if you have to follow along, going back to the previous question about decentralization, you can go to the StarkNet forum that I put it on the chat, the link, where we actually post our thoughts and ideas of how do we want to decentralize StarkNet. So you can follow the discussion there and the proposal, and you can comment.
Perfect.
Okay. Anything you want to add, David, regarding StarkNet, Cairo, ground? Again, if you want to share your Discord in the chat, so we can add you to the group we have in Discord. In case you haven't been added yet, please put your Discord there. Also join the Telegram community, where it's also useful in order to plan meetups if you want to do some in your cities, or you want to talk with us. If you have any questions, please let us know there.
All right, good news. It finished compiling. So we can move to the next step. Just clear the terminal here. So now that we have the Cairo 1 compiler compiled, we want to add these binaries to our path, right? So we can execute these binaries from any place in our file system. So an easy way to do it is just by adding to our configuration file for our shell. In this case, I'm using CSH, you might be using bash. So just modify this depending on your terminal. If you're using bash, it will be bash rc. Just basically adding the path where we compile, where the compiled version of the Cairo 1 compiler lives, to our path. So once with that, I'm going to just close terminal and open again so the changes takes place and we're able to find the binary. So if this goes well, we should be able to call the StarkNet compiler just to see the version. And what is happening? StarkNet compile, not compiler. And there you go. So we have the binary ready. The binary is added to our path, so we can use it to compile our Cairo 1 smart contracts to Sierra. So let's test that the compiler actually works. So I'm going to create a folder, just like a sample project. We're just going to put a very simple smart contract and try to compile that. So I'm just going to call this folder StarkNet. I'm going to get into it. And in here, just going to create just like a test folder, right? And I'm going to create two folders just for, usually I like to have one for where my source smart contract is and where the compiler folder. So just going to call the compiler folder Sierra. So this is how my sample project looks like. And I'm going to create a file for my sample smart contract inside of source. So we call it sample.cairo. Okay, so I put the tree again. I should see the file. So let me open this with VS Code.
David, a quick question. Is there some kind of prettier or ESLint for Cairo?
Prettier or ESLint? The closest will be this extension that we can install, but it's not exactly as prettier because prettier is a formatter. So I will say not yet. Something like ESLint, the extension will work similarly, but not like prettier that actually formats when you save or something like that when you execute it. How do we increase the font size?
Thank you.
Okay, here you go.
Yes.
So I'm just gonna put a very simple smart contract, right? And just gonna basically, we use this macro contract, and then we create a module. It's called simple storage. Right? For now, today is not the goal to learn Cairo 1, just to make sure the tooling is working. As you can see, we don't have any syntax highlighting or tooling or anything because we haven't done yet the work of installing the extension, but we have the smart contract. So let's try to compile it. So here I can just do StarkNet compile, and I provide the file example.cairo and then the output, and it's going to be a JSON file, the output. So it worked, right? Our compiler is working. This is how the Sierra looks like for this very simple smart contract. Good. So we have confirmation that the compiler is working now, the compiler for Cairo 1. Next step will be to actually install the VS Code extension. And the source code for that extension, actually, it's inside of the Cairo 1 repo. So let's go back to that repo that we store in Cairo. And we have here a folder called VS Code Cairo that we're gonna get into it, right? All right, we're in the right folder. So first of all, we're gonna need to have a Node.js installed. So in the case of Ubuntu, a simple way to install it will be with this command. There are multiple ways to install this. I'm just gonna use this to get the latest Node version 19. Let me just expand this more. It's gonna work. Let's see. So in theory, now I can do sudo apt update or I'm trying to install it. So now I can actually try to install Node.js. Let's see. Okay, so if it works well, I should be able to do Node and version. And yes, we have Node version 19, the latest one installed on the computer. So we're good to actually now compile the extension, or just, well, when you use JavaScript, you don't really compile. Let's say you package it somehow. So first of all, we need to have installed a global package called VS Code VSESE. So this is what you do for compiling extensions. So install it globally. It's under this name, ESE. This is provided by VS Code.
So remember, everything is being recorded and will be up in YouTube. So you will be able to, we'll send you an email with the link so you can review everything that we're doing right now.
Yeah, and the guide that I'm following also, we have shared with you the link. So you're exactly what I'm doing is just documenting in a nice document there. You can follow along. Okay, so now let's install dependencies for JavaScript with npm install. Remember, inside of the VS Code Cairo with the extension libs. Okay, let me just update my npm just in case that this is suggesting me to do. oops, copy, paste. Oh, I need to do sudo. This is just optional. All right. So now I can actually package the extension previous to be able to be installed using this command package. All right, that we install this binary globally from npm. Now we can use it here. This is just a temporary measure. Eventually, the extension is going to be published to the marketplace, and you will get it directly from VS Code without having to do that. But remember, we leave it on the edge, so this is how it needs to be done right now. So now we have the package, we can actually install it to VS Code with this command. Right? Sol extension, this is the file that we just created now. We go ahead, and in theory, should be installed. So let's try. Right. So if I open the extension here, okay, I can see that it is now installed. Cairo 1 is called extension, but we need to be configured because it's asking for where's the path for this particular binary, the Cairo language server. This is one of the binaries that we compiled from using Rust from source. So we need to provide this path. And to provide that path, let's go back to, that's going to be the target release. Let me just go back here. Let's go to target. This is where all the binaries are placed. This is my absolute, let's say, path to it. I'm just going to copy this. I'm going to put it here and a slash with the name of the binary. And I think I need to probably close this and turn it on again. So it takes, see, let me close VS Code. And oops, I need to go back to my work folder, or maybe just open here. And it's not taking, okay, now it's working. So now I get syntax highlighting and it's gonna complain you do some things wrong, like in this case, right? So it's a nice helper when you write Cairo 1 code. So cool. So we have the VS Code extension working. Yes, Omar.
Sorry, it's worth mentioning that, as David said, I want to repeat that we're not learning Cairo right now, but we will do. And we will have the chapter of the book ready for in a couple of days. So you can start learning Cairo by yourself, and then we can come here and already with more knowledge of Cairo, and we'll also teach you some Cairo. And also we have some tutorials like startings we will share in a minute, so you can start also learning Cairo.
Yeah, today it's just about the dev environment, not really about Cairo. But let me put a little more complex Cairo code here, because we actually want to deploy it today. Oh my God, fixed. Yeah. All right. Again, I'm not going to really explain how this works. We're going to talk more about Cairo in future sessions. I just want to make sure that we can compile this and we can deploy it to StarkNet. So let me just recompile this as we did before. If you ever go back to, oh my God. Okay. I'm just going to copy this. All right. Copy it. Can I paste it here? No. Anyway. StarkNet compile. Okay, so we compile in the new version of the smart contract. So this will be more complex now. As you can see here, right? Way more complex. So this is the code that we actually deploy to StarkNet that we give to the sequencer, the Sierra smart contracts. Okay, so let's keep moving on. The next step now, because to interact with the StarkNet, we used to use the StarkNet CLI. And the StarkNet CLI is written in Python, so we need to have Python 3.9 in particular to be installed in our system. So to install a very particular version of Python, at least on Ubuntu, you will need a particular PPA. This one here. Every time. Unify this, okay. So I add this repository to my apt. It's because we need Python 3.9. We installed Python 3.10. It might not work. Now I do update references. And I'm ready to install Python 3.9 using these two packages, especially for development, because we also need to have virtual environments. Thanks a little bit. Okay, if it all went well, we should have now Python 3.9 installed version. Yeah, there it is. We do have it. So now let's actually install the Cairo CLI. So to use the Cairo CLI to install it, we need to have one global dependency called GMP. So you can use this command to install it. This is required for the Cairo, for the StarkNet CLI, not the Cairo CLI, StarkNet CLI. You need this global dependency. Now, let's go back to our project that we were working on. Call it StarkNet test. Okay? We're back to our project. And I'm going to create a virtual machine here a virtual environment for Python. So when I install packages, I don't want to install it globally, I just want to install it per project. So to do that, you do this command, you define that you want a virtual environment, and then you give it a name. I'm just going to call it Cairo. All right. And then you activate that virtual environment so you can start installing. It's called Cairo. Cairo bin activate. So as you can see, now we're inside of the Python virtual environment. So we can install the Carolang package. Just before I do that, I'm just gonna upgrade pip to the latest version just to be safe. And now I can actually install Carolang. Pip install Carolang, which is gonna give you the standard CLI. Let's see. And it's installed for this particular project, it's not installed globally. If you are on a Mac, this might fail. I put some instructions on the guide. What's the alternative command that you can run on a Mac? Because it happened to me that it failed, so I found a solution. It's a more complex command, but it works. All right, so if this is working, so we should be able to execute the binary called StarkNet, which is the one used by the CLI. And there we have it. We have 0.11.0.2. Perfect. So, we'll use the StarkNet CLI. In every command, you will have to define to which network you want to deploy or interact. You use that with flags. And also you need to define which type of wallet. Remember that on StarkNet, every wallet is a smart contract. And you have to define to the CLI how this smart contract looks like and how this smart contract is able to verify signatures. So to be able to be a little bit easier for now and not going too much into detail until we get to those sections, I'm going to define two environmental variables on my shell that the StarkNet CLI is going to use and going to make our comments look a little bit simpler. So let me open my profile configuration, in my case HRC. Open. All right. Now go to the bottom, and I'm going to add two environmental variables. One is to tell every time that I run a StarkNet command that always targets the testnet, alpha girly, instead of mainnet, right? I don't want to spend money right now. And also to tell them, because it's a kind of abstraction, which type of wallet I want to use to sign transactions. So using this one here, Okay. So this should be export as well. It's not export. Export. If shit, it doesn't mess up StarkNet, blah, blah, blah. It's using a version of the Open Zeppelin wallet. Okay. This looks good. So I should be able now, if I close my terminal and then open it again, should be able to access these environmental variables. I do echo StarkNet network. There you go. So it's installed, it's available on our shell. So now next step, before we can deploy anything, we need to create a user account in our computer because we need to pay for declarations and deployments. So let's go back to our project for now. StarkNet test. Let me activate again the virtual environment for Python. Cairo. Bin. Oops. Activate. Okay. So because the StarkNet CLI is only available in this Python virtual environment. So create the new account, at least to get the address of our user account. We use this command, the StarkNet new account, and we give it a name. Oops. Right here. Right. So using the StarkNet CLI to create a new account in my computer, and I'm going to give it a name, just going to call it the 0.11.0.2, right? So I can add different wallets once the network keeps upgrading. So by doing that, it's not going to create the user account yet. It's just going to give me the address, because the address is always, it can be known before you deploy, because it's just an algorithm that will be always the same. So this is will be the address of my user account while I deploy it. So I'm just going to copy this one here. And the next step is just, I need to send test if to this account. I need to fund my wallet even before the wallet exists on chain. This is called the counterfactual deployment, I think it's called. This is a common feature when you have a kind of abstraction. So I'm going to send a small amount of ETH to this address. So let me open, I think I should have a wallet here in this VM that I could use. Oh, no, maybe I don't have. Yeah, I have to send it from my. So let me just bring this up. Give me a sec to unlock my wallet, not without sharing my key or anything. Just a second. All right. Okay, so as you can see, I have Bravos here. I have another account which already has some test ETH on Girly. So I'm just gonna send some test ETH there. So I need just to copy the address. And from here, just gonna send some amount. Let's send 0.05 test ETH. So I'm using Bravos. It says that it doesn't exist on chain, which is fine. This is the counterfactual deployment. We're going to talk more about that when we talk about account abstraction in future sessions. For now, just follow along. All right, so I've sent a transaction to StarkNet testnet using my wallet. I can follow a lot of transaction here on a block explorer. So we need to wait until the transaction gets at least to the pending state before we can continue. So I think right now on testnet, blocks are produced every 3 minutes, if I'm not mistaken. That's where you see the counter. So let's wait a little bit. Let me increase the font size so you can see better. So once we get to the pending state, it means that I have the funds available on that particular wallet, and I can continue with actually the on-chain deployment of my user account. Again, this is a feature of account abstraction. Hopefully we can make it easier for you in the future with tools like Scarp that we haven't talked about it yet. Questions in the meantime? Omar, or people, just post questions.
We don't have a lot of questions. We have a question from Michael, sorry, Michael, for the late reply. He's having some trouble compiling. There are a couple of questions for you there, Mike.
Yeah.
Are you using a log local, Michael? And the second question is, are you using what version of the compiler? Can you check starnet/compile/version, please? Or if you're using Scarp, let us know. Scarp is using the newest compiler version, because I think there's a problem with that part. Okay. Dimitri is asking, it would be nice opportunity to showcase faucets.
Oh, it's a good
Okay.
point. Yes. In this case, I'm sending Ether from another account that I have, but you can actually use a faucet. Where is it? Tools, faucet. There you go. I'm gonna put it in the chat, the link to the faucet, where you just put your address, and it will give you some amount of it. The faucet has the limitation that it has a limit of how much test ETH it can give you every 10 minutes. So if I try to use it now, I'm gonna say, oh, you have to wait 10 minutes, and I don't have time to wait 10 minutes. That's why I went the other way. But if you have more patience, you can use it this way. You will get some test ETH on your address. Okay, so now that we have, yeah, Omar, go ahead.
Sorry, David. Here, Glim is... Okay, go ahead. Glim is mentioning something very important in the chat, but we can go ahead and mention it later.
Okay. So now that I have test ETH associated with this address, I'm actually going to deploy my user account, which is a smart contract, to this address. So let me get back to my notes, put in my secondary screen. Okay. So to deploy my user account, just clear the screen here. I use this command. So again, use the StarkNet CLI. Now use the deploy account command. Always using this particular account that I created before, the one that we know the address. So if I do that, it's going to actually deploy my user account to testnet. And you can see, so it sends the deploy account contract transaction, so we can follow along the transaction using this hash. StarkScan. StarkScan. Where are you? Testnet. Put here the transaction hash, because we need to wait until it gets to at least the pending state. That's when we know it's ready to be used. Because what we really want to do is to deploy the Cairo 1 smart contracts that we were I showed you before that we have in VS Code. Okay, so it's on the pending state. So now we technically have now a user account that we can use to deploy and to invoke transactions. Cool. Let me just clear here, and let's go back now. So before we can deploy a smart contract on a StarkNet, you have to first declare it. The reasons we're going to explain it in the next session, but for now we're going to execute this command. Just going to try to explain what it does. So basically, it's going to upload our the Sierra code of a smart contract, using this account to pay for fees, for gas fees. And declaring is the previous step before you can deploy, because on a StarkNet, you can deploy multiple instances of the same declared code. We're going to talk more about that when we go to a kind of abstraction. For now, just follow along. So when we try to execute this, send this transaction to testnet, it's going to fail because this smart contract was declared before, actually by me. So it should tell me there's an error. Yes. The error is that it says the class hash, blah, 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 is already declared, right? And that's what I was expecting. That's fine. It means that I can just go directly to the deploy. I don't have to declare. But because sometimes you don't know, it's better to just try to declare and see if it fails, and you can move to the deployment. So, oh, wait, did I copy what was the address that I used? The address of my account. Just a sec. Try to find out to which address I send the account. Cash number, transaction center address. Sorry, just a moment. All right. Yeah, I forgot to take note of what was the address of our user account, but now I have it. Because we need to send the deployed transaction. Let me try again the declare because I need to take note of the class hash, which I didn't do before.
So some people are having trouble using the faucets, so it's very understandable. We are sending you each. Or David, do we have a method to send it each without using the faucet right now?
No, right now. There's something we talk right now how to do better because we know the faucet has a limitation.
Yes, so we have a lot of people right now asking for it.
Yeah, no, that's something that we that's why we kind of knew, but it's hard to get around. Hopefully, that's one of the things that we need to improve for next time we do Basecamp, for sure. So to deploy the smart contract, we need to provide the class hash that is provided here in the previous account. I'm just going to remove this because this is a previous thing that I did comment. And the class hash is here. And with this, we should be able to deploy our smart contract. Okay, so the transaction was sent for deploying our smart contract. We can follow along here. I need to remember to not delete anything from the terminal because I need those addresses. Paste. Paste. Here. Okay, so this is transactions to deploy the smart contract that we wrote in Cairo 1. So we need to wait until it gets to the pending state before we can actually start interacting with it. So let's wait a couple of seconds. Is there any question in the meantime, Omar?
No. Michael is asking, will there be a Rust-based CLI? And the answer is yes, there would be. It will be soon, but don't worry, the Python one is going to be working very soon. And it's going to be the same. Also, a lot of people are asking for it. Maybe, Mamit, if you have some it and you can help me send to Thomas, please, that would be great. In the meantime, let you know that all the transactions that I made, I send you the it, and you should be able to find it in your. Now you can deploy your wallet because the transactions were successful, so you can deploy your accounts.
Yeah, so our smart contract has been deployed, so we can actually now interact with it because we know the address, this one. And as we can see, you can see first of all there is a Cairo 1 smart contract, and we can go to the read-write section. And if we compare to our code, you can see that our smart contract had two functions, one to increase balance and one to get balance. This is read-only, this is for modify the state. And if you see in this Explorer, you see the get balance. Right now, it's going to be 0 because it has no value. But we can actually use the write to increase it. I'm just going to connect the wallet. Wait a second. That's one thing that I didn't prepare for, to install a wallet here. So let me just do it on my Mac. Copy.
While let me explain this, Rafael is asking, can we bridge girly it to StarkNet? Yes, we can. You can get some ETHs. For example, you see in a faucet, I don't remember the name, Paradigm has a faucet that can give you girly ETHs to layer 1, so you can send it to your MetaMask account, for example. And then from there, you can bridge it using the bridge. I will send you the link in the chat. And you can bridge it to the, actually, Clement already shared the bridge. Thank you very much, Clement. Stargate.starknet.io, it is on the chat. So you can use that to connect your MetaMask account to your Parables or Argent account, and then you can bridge that to your account. So it is relatively simple, yes.
Sorry, just gonna. We can go back to questions after.
Perfect. David, just something very quick. So I think some people might be leaving right now because of the time. So is there any question? What is it? Sorry, what is the homework? Is there any homework for next?
We'll send it in the email. We'll send an email with the instructions.
Okay. We'll send you an email. Thank you, guys.
All right, so I'm just gonna send the value 10 to the increased balance used in my wallet. I'm gonna sign this transaction. And then we wait a little bit until it gets to pending state. So we should be able to do the read operation and see the value at 10 coming back. So let's wait a little bit. Let me see what questions we have. When will the mainnet support Carol 1? Okay, we answered that one. It's already. Oh, are we sure, Omar, that it's deployed to Carol 1? Cairo 1 is deployed to mainnet? Because Michael is saying...
No, it seems like it's a little bit more complex. Like like a contract has to be tested for a while and then it can be uploaded to the mainnet. So we cannot do it right now.
Gotcha, didn't know that. Okay, the transaction is about to get to the pending state, which is a little bit. It means the block.
While we wait for that, an anonymous attendee is asking, is having an error while deploying the account. It is called started error code uninitialized contract. It is likely because you haven't sent it to your account and then deploy the account. So you have to first, as David showed, you first have to send to the address of your account the it, and then you can deploy it.
So there you have it. Now, sorry, I thought you were finished. I queried the balance again. Now I get the value 10. So to confirm that actually our transaction went through and modify the state of the smart contract. So now we can read the new value. So that concludes the tutorial to set up the environment. It's a long one. It's a complex one. Again, Cairo 1 is fairly new. So hopefully, just to do a brief summary, we had to install Rust, Python, and Node.js. We compile the Cairo 1 binaries using Rust. Then we configure those binaries to be available anywhere, adding to the path. Then we install also Carolang, and we install Python to be able to execute Carolang, and we install the VS Code extension as well. So you get this nice syntax highlighting and some easy errors to spot there when you write. Thank you very much for staying so long. It was supposed to finish a while ago, but it took longer. Hopefully it was useful. You have the guides there, and if you have more questions, please use Discord, and hopefully you will be able to use the faucet eventually and get some test ETH.
Yes. Also, if some of you are not able to get some ETH, let us know, please, in the Telegram. So I sent it to as much people as possible, but I run dry. So I will need to recharge. But let us know in Telegram, please. I won't be able to store all your addresses right now. But send it to the Telegram or bridge it. And thank you very much to Clement, who helped us a lot in this. Also, Glenn, thank you very much. And Glenn mentioned also something very important, that you have to change your contract hash. Okay, no worries. We'll see it the next time, and we'll add it to the book. So thank you very much, folks.
Thank you. Take care. See you next week. Bye-bye.